Welcome to Module 8, which focuses on the product development process, specifically lean product development. Now, the product development process for most companies is their innovation process. Whether their product development is to sell services, mainly for products, whether you're designing and building aircraft, or automobiles, or machine tools, capital equipment, or food production, there's always a product development process coming up with the new products, the new ideas. But you can have a product development process that comes up with new services. So a thoughtful, systematic process to come up with new services in management consulting, for example. So for example, in consulting, if artificial intelligence is an emerging market and the use and application of it, what's your product? What's your service that you're going to provide companies and clients who are going to implement AI? So you need a systematic product development process, and that's what this is about. In the previous modules, I introduced the whole concept of an enterprise, business process-driven enterprise, and I actually showed you the phases and stages as you go through the core product development process, which is the innovation process. Now we're going to look at optimizing that process. And what's really emerged in the last 10 to 15 years is a diffusion of knowledge from manufacturing lean, specifically with Toyota. So lean approach in manufacturing systems and manufacturing processes into the product development process. And that's what this is about. So, and it's also, I actually attended a lecture, this Ron Masticelli, President Technology Perspectives, and took notes, and this is a result of those notes. So the agenda, visioning, this is all about coming up with the principles of a new product development process. And then in Module 8.2, I'm going to discuss the actual Toyota's thinking about product development. So we're looking at the marketing requirements event. Product is all about what's your market want, and you don't design a product or a service if there's no market. So you've got to be marketing centric, and that's often called voice of the customer. And I have a special video on that also. And then the whole concept of visual workflow management. So as you're designing your product, let's say an aircraft, what are the deliverables through the phases? And I use that a lot in my examples because I've worked heavily in aerospace, but also in machine tools and in newspaper industry, food production as well. So there are three dimensions in product design and development. There's the production cost, so you've got to design your product for the lowest production cost. It's often called design for manufacturability. Also for the aftermarket, design for maintainability and sustainability. The other area is time to market. How fast can you get your your product to market or your service to market? If you're a laggard in terms of getting your new product, your new ideas to market, your customer, a competitor will beat you and maybe capture a lot of that upfront marketplace. You can also lag a little bit and learn from what your competitor does, but you can't lag too much. So it's a very delicate balance, allowing them maybe to lead a little bit, but not too much, or they'll capture the market. But maybe you'll learn from their mistakes, etc. And that's all to do with marketing timing. And then lean innovation or lean product development also focuses on market price. So lean product development helps you reduce your time to market. So let's say you have a machine tool and it takes 24 weeks and suddenly you've got a competition that can get it in 20 weeks. You can lose market share because of those additional 4 weeks that are late. Certain time is everything to certain companies who need their product, their suppliers to provide them their machines fast. Now in production costs, we look at design for manufacturing, the 3 Ps of Toyota, we'll go through that, the value engineering, getting rid of waste, and then the design for Six Sigma. Everybody probably knows about the Six Sigma, reducing variation in the process in order to reduce failures. And the lean product development, slashing time to market by improving the business processes, having concurrent engineering. We talked about that in the previous modules. And lean innovation for market is rapid innovation, scenario brainstorming, and set-based design. We're going to talk about that. And I'm going to give you an example of this set-based design that Toyota used. It also can be called rules-based engineering, where you follow a strict set of rules that are based on best practices, and you answer those rules about the product, characteristics, functionality, etc. right up front. So it's all about productivity equals profits per hour of design time, efficient utilization of designer development time. So if you're paying a designer $100 an hour, can you get $200 of productivity out of them? That's their whole idea. Faster time to market, go from 24 weeks to 16 weeks. You're going to capture the market. Higher profits for the firm. Obviously, the owners want more money at the end of the year, either to go spend it on their country homes or, of course, put it back into the business and expand the business. So use the money to build the business, invest in the business. More customers are satisfied more of the time when you have higher productivity and lower costs, and maintain quality. More fun for the designers who are free from wasteful, boring activities. That's about wasteful, meaning meetings to fix problems. That's a wasteful meeting, isn't it? That's a wasteful amount of time. Going to a meeting to fix a problem that shouldn't have happened in the first place. For example, you design a component that can't be built, and the factory worker says, the tool maker says, look, can't build this. You haven't designed it around the capabilities of the machine, so you're going to have to redo it. That's waste. Wasted time. Who tolerates waste? Well, profit, non-value added work, value added work. So the value added work leads to the profit, but the non-value added work, error loops, going back and having to redo it, unnecessary wasted steps and meetings, poor handoffs from one department to another or one process to another, undefined roles. I thought that was my role, but he said it's his role. We're both designing the same, doing the same calculations. Why is that? Low value meetings, lack of information. In other words, you know, there's no visibility. That's what the IT systems are for. But if you don't have good functional IT systems, you can't find information. So let's say you're looking and searching for a similar design from before. If you can't do design reuse, that's not helpful. Excessive multitasking. Missed target cost. Target cost is, for this particular component, a door, I should be able to design that to be built at $100 or $200 unit cost. Well, that's your target. Well, maybe it comes in at $300 or $400, double the price, which therefore contributes to the overall price of the product and therefore losses. Lack of prioritization. What's important? The 80-20 rule. You'll find that 20% of your activities are contributing 80% of your success. And constant interruptions. You know, the thing about design, anybody who has done real engineering design, I've done mechanical engineering work, and I know that when you're engaged in the design of a machine or a system or a tool or whatever it happens to be, or a product, you can go 15 hours of uninterrupted thought. Now you get tired after a while, but because you're analyzing every detail, every step, every dimension, you're visualizing it how it's going to be built, so you're detailing it, etc. Being interrupted constantly, because there's a learning curve in design. Once you go through it and you get firing on all cylinders, you do not want to be interrupted for meetings, etc. Top 10 sources of new product development waste: chaotic work environment, constant interruptions. Yep. You want your designers to be, you know, free of, probably in their own cubicles in that sense, but free of distractions. Lack of available resources, you know, the right people. You only have to have one skill. Let's say it's a person that does finite element analysis, and they happen to be ill for a week, and you've no backup to do the analysis before you actually build a product, that to make sure that the actual design is fit for purpose. And before you actually start machining it, you have to have a finite element analysis done. If that person is ill or you haven't a backup, you've wasted time. Poor communications, obviously, again, having systems in place where you have meeting minutes, proper meetings management, proper IT systems that support communications, disruptive changes to the product requirements. One of the worst things can happen is that the owner of the business promises his customer or her customer, we'll get that job done in 24 weeks. Just give us your design, give us your requirements, and I'll push it through the system. Because it might be a big company and they want to try to maybe get them as a repeat customer. The worst thing you can do is just take their requirements and throw it in without having a conversation with them about those requirements right up front. This is one of the things you're going to learn in this module. Spend a lot more time up front with your customers. in terms of capturing their requirements. Now what happens, and this is a fact, is that you may have customers that are just wasting your time. They're learning from you in order to go to another customer and get it cheaper. But while you're teaching them all their requirements, etc., they're just learning, they're wasting your time, and that is a delicate balance. So you have to balance the time that your engineers, highly paid engineers, are spending with customers up front, getting requirements, and then that customer doesn't actually buy, they take off. So owners of machine shops and machine tool type companies where there's customized machines been built are always nervous because they don't want their engineers' time being wasted by a customer that actually doesn't buy, that just picks their brains. So you have to be careful of that. But it's one of the worst things is to just throw it through, take the order and not spend that upfront time and freeze the design. Because if that customer is not sure what they want and you've already in detailed design and they say, oh, I want the concept to change, you've got to go all the way back. It's a waste of money. Now they can do it, but you have to charge them for it. So these are rules that you need to set up front. Lack of early consideration of manufacturability. It's a big problem in North America, not so much today, but it was, where Japanese, etc., most were trained in production engineering and manufacturing engineering environments. They came from that into design. That was the old British system as well. You started on the shop floor, you started in an apprenticeship. I don't mean this business of going away for a year and a year at school, a gap year, or even an internship. I'm talking serious 5 to 7 year apprenticeships where you're doing your degree or your diplomas while you're working on the job. And I mention it throughout many of my videos. And so when you go through that as a young engineer starting out, you understand how things are built because you've used machines, you've touched the physical machining process, the fabrication processes, the assembly processes, the disassembly processes. So then when you're in the design office, you understand how the factory runs. But if you're just a graduate engineer with very little exposure to how the factory works, how components are built, you're at a big disadvantage, and it's a big complaint from industry. Now, I know most universities have a machine shop course and so on, but that's just an introduction. That's not real day-to-day working on the job, getting paid for it. When you're actually paid money to produce in the factory or wherever you are, this is where you really, truly do learn. Otherwise, the rest of it's school activities, which is fine. It's an awareness, but it doesn't create real deep skills. Unfortunately, they have to be acquired in the workplace, and by that time, often it takes too long because you're in a different mode of learning when you start in your full-time job. So over-designing analysis paralysis. Yeah, over-designing machines, like giving them 3-inch walls when they only need an inch wall, for example, like a machine base. Making it out of a steel that's very, very expensive when a less expensive steel will do the job. I mean, the material substitution, which can save you a lot of money, should be considered right up front. You don't want to build all this stuff and then try to do it later. Too many meetings, big problem. That's why I'm a fanatic for learning how to manage and run meetings, agendas, minutes, action register, and then the first thing you hit when you come back to the meeting, the next meeting, is what's the action? What was achieved? And we call it, in practical day-to-day meetings management, we call it the 3 Ps: purpose, process, payoff. Not the 3 Ps of Toyota, which is a separate matter, but the 3 Ps of meeting management. Email overload, we know all about that. I mean, I'm getting on top of that recently. When I see an email, if it's of no value, I delete it, and I'll also block it if it really is a nuisance, or maybe I get somebody's promoting something to me all the time. I've started to become very, very, very diligent, and I have my emails down to 14. And the reason there's 14, not 114, 14. And the reason is that some of them, I need to do deliberate thoughtfulness about them. That's why I've left them. Identify non-value added waste. One of the fundamentals of non-value added, you learn in manufacturing lean, is would the customer be willing to pay for that particular activity? They certainly don't like paying for you to redo the design. So if it costs you $10,000 to design at the concept stage, and you put it to detail, and suddenly the detail design people, the preliminary design people say, oh, something's wrong here, this system's not connecting with the other system, then you have to redo that concept design, and it's costing another $5,000. your customer will be very upset if they're having to pay for it. And if they're not having to pay for it, you're losing it. So your owner, the owner of the company, your shareholders, they're your customer as well. They won't be too pleased. So value-added activities. Type 1 activity is an enabler. It's non-value added but currently necessary. And type 2 is waste. It's not necessary. So there are certain non-value added activities that, right, because you haven't designed your process correctly, that you need to keep them, but they're not necessarily highly value added. But your processes are so broken. So you may have multiple design reviews. They're necessary because you haven't built the ability to design the product right the first time at concept stage. So maybe you have lots of mini reviews and lots of talking. That's because the process itself hasn't been optimized. So waste elimination through lean. Current state, this is the value added, this is the enabler, and this is complete waste. What you have in a future state lean is you've much more activities that are truly the value added, the high value. What would you have engineers doing, calculations and design and testing and so on of the product before it's ever built. And here's the enablers, what you wouldn't call they're not value added tasks, but they're necessary. You still have to do them until you lean out the process or do some re-engineering. Our goal is to eliminate type 2 wherever possible and minimize type 1. Okay, so it's not a black and white thing. It's not you've only value added or non-value added. There are processes and activities that you conduct which you couldn't consider as value added, but they're necessary the way your system works. This is over-the-wall development. This was the word that I knew, that I grew up with, and before all the competition from the globe came, from the global industries. You had a new sales and marketing threw it over the wall to engineering. Engineering threw it back and said, failed prototype, redo it. It was a revised specification, and then engineering finished the design, threw it to manufacturing. They came back and said it's an unacceptable unit cost. Then engineering change orders both ways because it had to be redesigned and then launched. But there's all this back and forth, big problem. There's the whole concept of phase milestone or phase gate process. Now you'll also hear about a concept called stage gate process, and that's a fellow out of McMaster University in Canada called Dr. Cooper. And he came up with this stage gate, which really focuses on fast-moving consumer goods. So, toothpaste, food products, products that consumers use. It's not used at all in heavily engineered products like aircraft, military aircraft, weapons systems, automobiles. It's not used in those kinds of huge engineering driven projects. That's usually called the phase milestone process, and that's been around for decades. So be careful, the principles are the same. You have a phase of work, you have a milestone where you actually identify if that work is complete to move to the next phase. So if you have a review, then when you go to the next phase, you should be okay. You've satisfied that the deliverables from the concept phase are good enough to move in preliminary phase. So these are the gates. So the phase can be used as a transition stage from over the wall, but it's not an end in itself. So you've got, instead of just throwing it over the wall, you formally review it before you pass it on. Now, potential sources of waste in the typical gate process, too many of them. So too many of these reviews, too many gates, like you may have 15 of them, when maybe 6 could do. Too many process mandated activities. You can do analysis paralysis with your business processes, and we'll see this in the Toyota example I'm going to show in a few minutes. Process drains time from value creation. You can over-engineer business processes and bog engineers down and having to do all this reporting, having to report every detail that they're conducting and all their calculations and so on. Sometimes you can bog them down. Process is difficult to scale down. It's so complex a design process, and your product is so complex, maybe you cannot eliminate a lot of the detailed activities. Phases and gates distort the critical path. Yeah, because there could be a faster way to, if you just wait until everything is done here before you go there, then everything is done here before you go there, you may not be able to reduce the lead time, because maybe if you do 80% of the activities here at concept stage, Perhaps you can then move to the next stage without incurring risk. And then the other 20% you can catch up. But if you wait until all the activities are done, you're adding to your lead time. But perhaps 80% of the activities and decisions and designs are complete, which allows you to go into detailed design and then into prototyping. So you could still be doing some well, probably not when you're in prototyping, but still perhaps. But as long as you know that there's no fundamental showstopper changes. So it's about thinking, it's about a way of thinking about how to think lean, how to push things through without incurring risk. Attributes of a lean: focus on process of transformation of information, not on artificial structure. Don't want heavy-handed governance. You don't want endless amounts of process reviews. An event-driven process simplifies collaboration. Event meaning this milestone, we have to achieve it. Here are the specific deliverables. Emphasis on proactively managing risk. So all the way through, you're teaching your engineers to think about the risk of failure, the risk that it can't be manufactured, the risk that it can't be maintained, the risk of failure in the field. Can be scaled to any size of project, from 1 or 2 person team to a major development. So in other words, you're designing a process which can be scaled into large scale products or processes that or services that you're building. Simple, often visual tools you use to capture learning, track progress. A process based on philosophy that information must flow without interruption. So if you look at the product development process, it's all about knowledge. So it's about knowledge which creates information, and that information is passed through the life cycle of the product development process. So you want that information to be accurate, to be accessible, and to be usable and reusable. Very important, never forget that term, reusable. Overview of a lean product development process: you start with market requirements, your position, segmentation, prioritize requirements, the features of your particular product that they want. Is it speed? Is it quality? Is it functionality? Or is it a combination of all of them? And then the decision to go next. Basic project plan. This is where you plan your risk. Optional decision point here, because you go straight into cost reduction activities. Design, to try to look at, okay, so we've got our concepts. How can we reduce the cost? Like a deliberate process to reduce cost, which is also to do value engineering. Start questioning, brainstorming. Right, that's a good design. Now let's the real bright people from the shop floor, from the customer even, from some of your customer user groups, get in there and analyze it. And then you finish up with a design review and a freeze, prototype data, design validation, and then into production readiness, factory floor, supply chain. Okay, so these concept of voice of the customer and innovation problem solving, which I cover a lot in APS 1013, the Applying Innovation course. This is what you use in order to analyze in detail, try to get costs out of the product, etc. in the design review. What constitutes a great new product opportunity? Highly differentiated from other products, manageable risk, leverages your own manufacturing capabilities. Capability is another area of consulting that I've done a lot of work in, where actually companies bring me in and they assess their capabilities against world-class standards. So it could be their manufacturing capabilities in assembly, it could be their machining capabilities, it could be their sheet metal capabilities, it could be their sales capabilities, marketing capabilities, production flow systems and so on, product development capabilities. And I've got whole methodologies to do that. These are the consulting tools that one builds. And high net present value supports firms' strategic decision aligned with core competency. So these manufacturing capabilities or design capabilities are essentially the core competencies. This is a recommended criteria for marketing requirements. These are the categories of the product. So you've got a product example. These are many products: paperclip, tap water, original oil painting, tickets to see Bruce Springsteen, cost accounting, portable. Hopefully Bruce is still around when you're seeing this video. Fully customized software, digital alarm clock. So this is the criteria that the market requires, in terms of its importance. So from a paperclip, esteem, who cares about that? I'm not even sure why it even gets any grade here. Scarcity, that's not an issue. Retained value, again, that's not a big issue. Relative market price, they're so cheap. I mean, whoever looks when they're buying paper clips at the price of them, when you buy 100 paper clips. But one thing you want is you want them to perform. So when you put your paper clip, you don't want it breaking or bending or snapping off. You want it to be robust when you put it over your paper to hold the paper together. Now, in oil painting, oil paintings don't have performance. They're fixed. They serve to visually please you. So here you're looking at relative market price. I mean, that's how you look at an oil painting. The first thing you do is, how much is it? That's the very first thing people say. I like that, but what's the price? They don't start touching it and feeling it. Well, you're not supposed to. And is it scarce? Obviously scarcity. And how's that defined? Well, I've bought paintings back a long time ago, I won't say when, and some of them were bought for $2,500 and probably are worth 20 or, well, I don't know if they are, but I know that the similar painting of the same artist, because his esteem's gone through the roof, are now worth, you buy them for 30,000. So you see, total different, product and market space. But you're looking at performance, the esteem of a particular product or service, the scarcity, retained value, and the relative. And esteem, let's look at consulting services. If I was delivering my services to a company and I was competing with McKinsey or Booz Allen or Boston Consulting or KPMG or Pricewaterhouse, probably they'll have more esteem. But the one sure thing is when it comes to price, I will be a lot less. So there's a balance here in terms of what customers, and I personally have beaten these companies out in major assignments. That's just a fact. IBM at Lockheed, for example, and other companies, because I wouldn't have the esteem. My company wouldn't have any big esteem compared to those gigantic companies. But because I was known by the individuals paying for the service, they knew they'd actually get a value added. They'd get something for it. They would get something of value for it. And so the price wouldn't have been that important. Well, it was important, but it would my price or my company's price at the time would have been a lot less than the big six consulting firms. And there's no question about that. But it was knowing that they would get a result, and that's the performance, which would have been high on their value added. Overshoot or undershoot customer needs. Now, performance, if you design too much, give the customer much more than they actually need in terms of a functionality of a particular product, you miss the profit margin. So the more you overshoot, the less profit you have. This is profit. So the more you put in to the product, they're not going to pay any extra money for that. So if you make the walls 3 inches, and that's double the price for those particular walls for a particular base for a machine tool, then you're going to waste your profit. Similarly, missed value opportunities. You could have charged a lot more money for a particular product if you had given them a lot more value in terms of functionality, etc. of it. So this is a delicate balance. Not giving too much, but not giving too little. If you give too much and they don't need it, you're going to swallow the cost. If you give them too little, there's a missed opportunity for you to charge more. So it's a very delicate balance, but it's the thinking that you need. And even if you're in consulting or selling professional services, this is how you have to think. You don't want to overprice, but you shouldn't underprice either. And you should also not underperform, or you shouldn't overperform. You have to give exactly what is agreed to. This is just a spec sheet. I'm not going to go through it, but just it says product designation, what specific problems this customer wants solved, who are the customer's targets, what's our sales volume in year 1, year 2, what's the physical characteristics, what's the critical features, and what other characteristics. Look, a one-page concise statement of what your product is, no matter how complex that product is. Military aircraft, believe it or not, you should be able to get on one page what the value added of that is. I'm not suggesting you all go into the military whatsoever, but it is powerful engineering technology. So it's an engineer's playground, I'll tell you that, for speed, flexibility, maneuverability. Wow, is it ever? But then you have to have if you have a moral mind or an ethical mind, you have to look at what the end result is. But this is a way for you to synthesize a product The market requirements event, transform the voice of the customer. I've got a whole video on this, so I have, and I think it's in this particular module. And a prioritized list of product requirements. So you're listening to what the customer wants in terms of functionality, features, and so on. And you're doing a formal house of quality as well, looking at those of how they will be built, how those features will be achieved. So each feature is also given a rating in terms of performance. So preparation for that market requirements event or voice of the customer, initial concepts, customer survey, ask them what they want, information on competitors' products, customer satisfaction. And the ones in blue are valuable inputs. The ones in black are essential. You just can't do it unless you have them. Warranty, return information, nice to have that. But target cost is essential. Your manufacturing constraints are essential. Your target customer groups are essential. These are not essential, but they're highly valuable. Projected capital requirements, you know, what machine tools and so on you need to buy. Assessment of technical risks. I would have all of them as essential, quite frankly. But we're just creating you can still get away with if you just had those in black, strategic goals of the new product. And this is another sheet, again, marketing requirements, planning and risk. And the 3P cost reduction is production preparation process, basically. How ready are you for production? Never, ever underestimate when you're in design and you're designing a product or a building or whatever it happens to be. Never underestimate the complexities of actually producing it, building it, machining it, manufacturing it, assembling it. And then design review meetings. And these are all the functions. So this is like a matrix. So functional supervisors, managers, production managers, etc. Cost and quality. I will have lots of examples of this as the course unfolds, real world examples of matrices, which shows you the mechanical design, electrical design, tool design, roll tool design, machine design, etc. Manufacturing, engineering, assembly, fabrication, testing, and where they should be involved in the decision-making process. So this is a typical agenda. You start at 8 a.m. till 5 o'clock, a whole day. One day is the minimum that should be allowed for the market requirements event. Getting together. Now, if you have 10 people in there, that's 10, let's say $100 an hour. It's a lot more than that, but just let's say $100. That's $1,000 an hour, and that's 8 hours. That's $8,000. That's $8,000. The owner's going to say, oh my God, why am I spending the money just to look at the customer requirements? Well, you'll see later, and you'll see through the Toyota system, that this is what's going to save money downstream. What does market positioning mean? Products positioned in the market's unique combination of performance, features, and prices and quality. It's the first thing people ask, how much does it cost versus that? How does it perform in terms of functionality? I'm going to wrap up here. A tool to identify the top 5 key differentiators. So possible key, you write them down here. Relevance buying, you decide for each customer what's high and low on their priority. Functionality might be higher on a priority than price, for example. I mean, for example, a weapons system. Trust me, the price is important to the United States Department of Defense, but higher than that is the performance, is its functionality. Is it going to actually take out the enemy? I mean, and they'll pay for it. So sometimes price is not the most important thing. Sometimes functionality is. And again, in all other non-military products, it's a combination of these matters. And so the top 5 scores are your top 5 features or differentiators for customer. There's lots of examples of this on the internet. Here's an example: high top speed, rapid acceleration. I think this one was for I put this in for a boat. Towing capacity to tow your boat. So this is a speedboat. Appearance of the boat, it's a 3 out of a 5. Well, it's a 3 out of a 3, sorry. So appearance, everybody wants their boat to look beautiful. Safety, 2. I would want safety, 3. Support scuba diving. Well, maybe you're not a scuba diver, but if it was for scuba divers, they'd want scuba diver capabilities. Supports water skiing for the most part, 3. So your current product, and then your competitor's product, where they fit, and then your competition product B, and then you can compare your differentiating, how you compare to them. Harnessing the voice of the customer, though you've got to weight the different requirements of a customer, whether it's product performance or its cost or it's certain features of the product. We must have scuba diving capabilities on that boat. That boat has to be so streamlined and beautiful looking. But if it's for another purpose, they say, I don't care how it looks, I'm just transporting drugs from A to B. I just want something that's reliable and functional. Forget how it looks. Obviously, you don't want to be doing business with people who transport drugs, but the fact is, everybody who buys these products have their own interests. All right, the lean voice of the customer tool, just fix that. Weighing the top factors, so your top key differentiators are here, your possible feature performance levels that could deliver a key differentiator. Again, I won't go through all this, it would bog you down. I just want to give you some examples that you can read for the speedboat. 200 horsepower engine, a 400 horsepower engine. This got high top speed. The average was a 4.3 here. Supports water skiing, got very high. Cumulative weight. These were the features of the functionality of the boat that met these differentiators, these criteria. And then you rank them. So the most important rank was the 400 horsepower. So this particular boat, the market sector that it was in was perceived to be for high speed. Of course, 400 horsepower would get you higher speed or higher startup speed than a 200 horsepower. Do you need to match the competition? In addition to differentiating your product from competitors, you may need to match one or more attributes of their products to ensure parity. But you're not differentiating. The next thing is you have to differentiate from them. Maybe achieving the same approvals, certifications as your top competitor, meeting industry standards for interfaces, matching your top competitors' features. The final step. You can't live without it, the must-haves, important differentiators, the should-haves, the niceties and options, the could-haves. This is a well-known thinking in marketing. Must-have, should-have, could-haves. You must give them what they want. And the should-haves, you can convince them, but they have to pay for it. And the could-haves, again, it's a third level of importance. If you lay it out for them, but again, they have to pay for it. I think I'm going to end there. Back to the same speedboat. In this case, I'll go to that one. Power plant has to be a 400 horsepower. They wanted that. It was a must-have for them. Next generation GPS, must-have. 20 foot to 24 foot in length, must-have. Now the priority, or should have, 3-motor catalyst gel coat. Standardized model T24, and here storage customized for scuba skiing. That was a could have. It's a way of thinking. Thank you very much. That ends 8.0.1.